we're going to start dividing fractions. But before we do that, let's just go over our learning goals. Model division of fractions using bar models and number lines. I'll be honest, we're not going to do a whole lot of that today. Compute and interpret quotients of fractions and interpret remainders in real-world problems. That is going to be a big piece. That's where our word problems come in, and dividing with mixed numbers. So 2 of the 3 major ones we'll get through today. We're going to start by writing the multiplication division fact family for each rectangular array. So just before we get started, because we haven't really talked that this year, who knows what a fact family is? Alina?
It's like if you multiply one thing like 4 times 2, and then you can also like divide it.
Okay. So how do I write the fact family? 4 times 2 equals
8. And
8.
8 divided by 2 equals 4.
8 divided by 2 equals 4. So that gives me my fact family, right? So I've given you rectangular arrays, so you're going to have to count to figure out what numbers you're using. But write the fact families for both of these pictures. I'll give you a hint up front. You should have 4 things listed for each one. So we'll give you guys about 2 minutes. Go ahead and get started. This is individual work. I want to see who knows it, not what the table knows. So individual work on. So who wants to get us started on the first one? Go ahead. It's okay. Yeah. Good. So what was my length? And what was my width? And that equaled 18. So how else could you write it? Good. 6 times 3. What else could I do?
18 divided by 3.
Awesome. I knew what you meant. Okay, so there's your fact family, right? Is everybody good with that? Okay, what about for number 2? Good.
So fact family is 3 times or 2 times 7 equals 14.
Good.
7 times 2 equals 14.
Good.
14 divided by 2 equals 7. And 14 divided by 7 equals 2.
Awesome. Good job. Yeah, make sure you sign out. Guys, do everybody understand this?
Yes.
Any questions on your fact families? Okay, so here's the deal, guys. The fact families become really important as we start to do our models. So do you want the good news or do you want the bad news? The bad news, if you can't understand all of the fact families, you're not going to be able to get the models at all. So now do you want the good news?
Yes.
We're actually going to skip right over all the models and go straight from 43 to page 53. Okay. Listen up, guys. Guys, remember we're recording. Please listen. So rather than go through 10 pages of models, we're going to do one model together, because I really do think it is important for you guys to understand conceptually what is happening when we're dividing by fractions, okay? So here's our model that we're going to do, and I want you guys to write this in on page 53. Your model is going to be 2 individual blocks. So mathematically, how would I represent that? Sawyer? How would I write that mathematically to indicate what I have in the model? 2 blocks I would write by the number 2. Good job. I know you can figure it out. That one was tough. Now, if I cut these blocks up, what operation cuts multiple things up at once? Division. So I am actually going to divide these 2 blocks, and I want to cut each one into 4 blocks. So I'm going to cut them by 4, right? So what would, mathematically, how would I write this one piece? How much of that block is that? Mathematically, how much of that block is that one little piece? 1/4. Is everybody okay with that? So what we've done, we took our 2 blocks, we divided them both into 4s, correct? Okay? So when I take 2 and I divide it into 4s, how much do I have now? How many blocks have I now made? Is there anyone who doesn't understand what just happened? Thank you for being honest. Okay? So let's just use our picture and count, shall we? If I count, how many blocks do I now have? I have 1, 2, 3, 4, 5, 6, 7, 8, correct? Does everybody see it?
Yeah.
Okay? Guys, here's why I wanted to show you a model to help you understand this. Normally, if I take a number, say 10, and divide by 2, what do I get? A smaller number, 5, right? But what happens when I take my whole blocks and I divide them into pieces? Now what happens? I have more pieces, right? So now, normally you think a division is getting smaller, but when I divide by a fraction, when I cut it into pieces, my number actually gets bigger because I now have more pieces. Does that make sense?
Yes.
So logically it makes sense, right? But look at this sentence. 2 divided by 1/4. Does that make any sense?
It does.
Doesn't to me.
It does.
If this makes sense to you, and you feel like you can solve this every time,
It does.
how? How does that make sense?
Because you're dividing a number smaller.
But mathematically, how are you going to do 2 divided by 1/4?
Switching the 4.
Oh wait, so you're saying you need to switch it, that you can't divide by fractions?
Yeah, so then you have
Interesting. Wow, this gets to our terminology. So let's look at our math terminology real quick. Get out your highlighters if you don't have them out yet. We have what we call a reciprocal or multiplicative inverse. Is one of a pair of numbers whose product is 1. Guys, please quiet down. It shouldn't take a lot of conversation to get out a highlighter. So to say this in English, a reciprocal means 2 numbers that I multiply and the product is 1. So if I multiply a number by another number and the product is 1, those are what we call reciprocals. The way you know it, the multiplicative inverse of a number, A over B, is the number B over A. One key in this, neither A nor B can be 0 because I can't have a 0 in my denominator. And when I flip them, that means that would be an irrational number. So A and B, the inverse is just literally flipping it upside down. So what's the inverse of 1/8? 8 over 1 or 8. What's the inverse of 2? No. 1/2. Remember, to flip it, if I have a whole number, it means that it's over 1. So to flip it, I put the 1 now on top. Make sense? So now, mathematically, let's look at what we are doing. And actually, let's write this out first. So we have space here below our definition. We're going to give you guys an algorithm for this. Who remembers algorithm? We just did that one last class. Tiana? Good. The steps to find an answer. So we're going to give you an algorithm for dividing fractions. So please make sure you're writing this in your notes. Okay? Step 1 is going to be keep the first number like it is. Don't do anything to the first number. Okay? Step 2 is going to be change. And what we're going to do is we're going to change division to multiplication. And 3 is indeed flip. Okay? So we're going to flip the second number upside down. In other words, we're going to multiply it by the inverse. Okay, so this is your steps for dividing fractions. Just like we can't actually divide by a decimal, we actually have to get rid of the decimal place if it's in the divisor, right? We also can't divide by a fraction. Mathematically, it doesn't make sense. So instead, what we are going to do is multiply by the reciprocal or the inverse. Okay? So let's see how this works. So we have our equation here, 2 divided by 1/4 equals 8. Well, let's see what it works like for dividing by fractions. Step 1, I keep. So I keep the 2. Now, because we're working with fractions, I do need to make it an improper fraction. So I am going to put it over 1, but I'm still keeping the 2 like it is. I'm going to change the division sign to multiplication. I am going to flip the second number. So what is the flip or the inverse of 1/4? Alina? 4 over 1. And now we're back to where we were last class, where we're multiplying fractions. So all I'm going to do is 2 times 4 equals 8. 1 times 1 equals 1. 8 over 1 equals. So mathematically, did we get the answer that my model said I should? Yes. So did this work? Okay. Now here's where we need to make a delineation. What did we just do? We actually, and I want you to write this phrase, what we did is we multiply by the reciprocal or the inverse. This is what we are doing. And Mr. Chan is very stringent on this one especially, that you guys understand what we are doing. How we are doing it, the algorithm we gave you, is keep, change, flip. Does everybody understand the difference? So the what is multiply by the reciprocal, the how is keep, change, flip. Questions on anything we've covered so far? Is there anybody confused about why when I divide by a fraction I get a bigger number? Ben? I'm sorry? KCF? The problem with calling it KFC is that you would get your order wrong. As long as you can do it, Ben, I honestly don't care that much, but I get very hesitant about changing the order because in math, order matters. So we're going to do one together, but then I'm going to let you guys do the rest of this by yourselves. So we're going to rewrite each division sentence as a multiplication sentence and then calculate the quotient. So there's 2 steps, right? Write it and then calculate. If it's a whole number, what's the first thing I need to do? How? Put it over 1. Then I can keep, change, flip. So you've got 4 to do. And if you finish those, I want you to look at number 3. See if you can figure out what happened on number 3. So we'll give you guys about 5 minutes. Should be more than enough time. Go. Okay, our first one. I'm going to go fast because we have a lot more we want to get through. This is just to verify what you did. So keep 5 over 1, change, times, flip, 4 over 1. 5 times 4 is 20. 1 times 1 is 1. 20 divided by 1 is 20. Simplified form. Keep 1/8, change, times, flip. Remember, if I'm flipping, I need to have it as an improper fraction. So that becomes 1/2. 1 times 1 is 1. 8 times 2 is 16. Keep 4/5, change, multiply, flip, 3 over 1. No reductions on this, so 4 times 3 is 12. 5 times 1 is 5. Simplify. 5 goes into 12 twice with 2 left over. Okay, part D, keep 3/10, change to multiplication, flip, becomes 3 over 1. No reductions. I do want to add a side note on this. For those of you that have actually been converted and understand how awesome doing reductions is, I cannot reduce in division. So even though I've got a 3 here and a 3 here, when it is division, I cannot reduce. Is everybody clear on that? Okay? If you do reductions there, it's going to mess it up. You can only reduce in multiplication. Okay? So that means I now have 3 times 3 is 9, 10 times 1 is 10. Everybody good? How many got all 4 of them right? Good job, guys. That's actually pretty impressive. Okay, how many of you got a chance to look at what Alexa did? Ben, did you figure out what you did wrong?
Yeah, she forgot making improper fractions.
Excellent. For the reciprocal, I have to do it as an improper fraction first. So for those of you that still don't understand slam dunk, all I'm doing, multiply the denominator by the whole number, add the numerator. So 5 times 3 gives me 15 plus 8 gives me 23/5. So what would the reciprocal be? 5 over 23. Guys, it's literally that easy to do reciprocals. All you have to do is flip it. Now, to get back to the definition of reciprocals, how do I know the reciprocals? Because if I multiply them, it equals 1. So I would put a multiplication sign just to check. Do I have any reductions I can do? You should, if you've done your reciprocals properly. 23 on top and bottom, right? You can divide both those by 23. 5 on top and bottom, divide both those by 5. What's 1 times 1? 1 times 1? 1 over 1. So are those reciprocals? Yes, they equal 1. So that is your definition of a reciprocal. When I multiply them, I get the answer of 1. How do I know what the reciprocals are? I flip it. That's how I know what the multiplicative inverse is. Does that help you understand those math terms? How you guys feeling on this? Pretty good? Okay, so let's take a look. We'll give you guys some more practice with word problems. Yay! Okay. Keegan, can you do me a favor? Can you read that out loud? It's in your book if you can't see it very well. You're kind of squinting. Show your work. Good job. So we all understand what we're supposed to do? Show our work. Guys, you have 3 problems. We'll give you guys about 5 minutes because we want to get some more practice in before the end of class. So you have 5 minutes. Go. Okay, we're going to go quick because we're almost out of time. 5 2/3. How many bags can you make so that each bag contains 1 5/6? One of the key things in a division problem, you got to determine what am I dividing? What am I dividing it into? So am I taking 5 2/3 into 1 5/6 or 1 5/6 and dividing into 5 2/3? 5 2/3 divided by 1 5/6. When I have mixed numbers, first step, slam dunk. 3 times 5 plus 2 gives me 17/3. 6 times 1 plus 5 gives me 11/6. One of the big problems with mixed numbers, kids do the slam dunk and forget keep, change, flip. Okay? Once I have my division written out with improper fractions, now I keep the 17/3, change to times, flip. 11/6 becomes 6/11. Look for your reductions. It's going to make life much easier for you. I have a 3 I can take out of the 6 and the 3. Gives me 34 over 11, or 3 1/11. Am I done? No, because I have a question to answer, don't I?
Yeah.
How many bags can I make?
3 1/11.
How do you make 1/11 of a bag?
You break them into 11 pieces and you only have 1. You empty the bag out, and empty the bag, and then you put 1 of 11.
Guys, can I make 1/11 of a bag? Really?
Yes. Just cut the bag up. That's it.
Okay. Does everybody understand what the question is?
Yes. Just cut up the bag.
How many bags can I make?
3.
3.
3 with 1/11 left over.
Thank you. I can make 3 bags with 1/11 left over. Okay? So really, you can only make 3 bags. You have 1/11 left over. Now, if this were a test and you had said 3 1/11 bags, would we give you the credit? Probably. But this goes back to our learning goals, which is understanding what the numbers mean in real-world context. In real-world context, what this means is I can make 3 bags, and I've got 1/11 left over. Everybody good? Okay, a cook made 47.5 cups of mashed potatoes. If there are 1 1/4 cups of mashed potatoes in a serving, how many servings did he make? So, in the sake of time, 47.5 divided into 1 1/4, correct? Yes, 1 1/4. First, slam dunk. So, 2 times 47 is 94, plus 1 is 95. Divided by 5/4. Keep the 95 halves. Change the times. Flip 4/5. Here's where reductions become your best friend. Because I can do the 2 and the 4 by 2. I can do the 5 and the 95 by 1. So now it's just 19 times 2 is 38. 1 times 1 is 1. Or 38. Those of you who did not do reductions, you got some nasty numbers. Okay? As long as you do the reductions, this one's easy. So he can make 38 servings. And our last one, hiking trail, is 9 3/5 miles round trip. If you hike 1 3/5 miles an hour, how many hours will the trip take? There's our question. So we have the 9 3/5 being divided into 1 3/5 sections. Gives us 45 48/5 divided by 5 8/5. Now we do our keep, change to multiplication, flip. Let me rewrite that one. That bar on that 5 came up funky. And again, reductions make this very easy. I have 5s on both sides. Those become 1s. I have 8 and 48. I can divide both by 8. Now it's just 6 times 1 is 6. 1 times 1 is 1. My answer is 6. If you did not do reductions, I feel sorry for you because those are some not nice numbers. If you did reductions, it will take 6 hours. Are you guys understanding the importance of reductions? Make sure you only do it when it is multiplication. You cannot do it in division. Can't stress that enough. Okay, unfortunately, we're out of time to do our extra practice. If you want some extra practice, guys, quiet down. If you want some extra practice on the dividing, 59 and 60 are really good practice. But let's go to page 61. This is your homework. Okay, the first part of your review on page 61. This part, I'll be honest, isn't as important for your quiz, but it does give some very good review on some of the concepts we have covered. Shouldn't take you very long. The end of topic review is really the most important part. Okay, number 8, there's 2 parts. They've given you 2 sets of numbers. Determine the GCF of each pair. So I would also find the LCM just because you can very easily, but you got 2 problems there. Number 9, write the prime factorization. Make sure you do it from smallest to largest when you're writing it. Okay? Remember, the prime factorization is a multiplication sentence. You can either do factor trees or the cake, but once you have the numbers, rewrite them in the sentence. That's what prime factorization is. 10, I want you to cross out the draw a model. We're not doing that. We didn't cover it. We just want you to solve them. Realize there's 2 parts to this. That's why I drew this line here. This part B is part of number 10. Number 11 is using granola to make a batch. How much granola does he need? Oh, I did that wrong. I hope last class watches this because this is actually a multiplication question. So he uses 4 cups to make 1 batch. He's making 2.5. So you're going to multiply those 2 numbers. Okay? And number 12. Use a factor table. You can cross that out. If you do, I want you to do GCF and LCM. If you choose to use the factor tables, you have to fill them in properly. Okay? Is the factor table just a list of numbers? No, it's not. It's filling out the tables properly. I highly recommend do the GCF using cake. Number 13, this is our division problem. But they give you information, make sure you're answering the question that is asked. That's the only extra advice I'm going to give you on that. Number 14, you can cross out A and B. You don't have to do the area models. We didn't cover those. I'm not going to expect you to do it. I do want you to use distributive property. So if the model will help you on that one, because we did do that, that's back at the very first section. You can draw one quick model, but the biggest thing is make sure you use distributive property. Questions on your homework? Sawyer. For which one?
GCF.
GCF. I crossed out the factor tables and made it cake. If you do the cake, you need GCF and LCM. Okay, guys, should be relatively easy. Don't forget your quiz on Monday.